Okay, so we'll go ahead and jump into it. This webinar will be recorded, so if you miss part of it or have to step away for a little bit, we'll provide that information on where that recording is located. For those who are able to make it today, welcome. Today's webinar will be UAS inspections. My name is Mike Clarenbeek. I'm a UAS specialist here out of Sioux Falls, South Dakota, so I'm located in the Midwest. Phil Jans, he's also on the call. He's located in our Denver, Colorado office. And then we have Nathan Stephenson, who's going to be in Denver, Colorado, and he's going to be answering some questions for us. If you guys have questions as we're talking, feel free to type those on the bar on the right-hand side. There's also a chat, which we'll have some information in, but feel free to ask questions as we're going. And Nathan would be happy to answer those live, and if we can't get to them, or if there's a question we don't know, we'll make sure to mark that down and then get back to you after the webinar. Okay, the rest of our staff for UAS operations, we also have two other individuals, Chris Kelly out of our Seattle office, and then Christopher Rice out of our Boise office. There's our contact information there, so if you need to get a hold of us, you can either email us at uas@frontierprecision.com, or you have our phone numbers there, so feel free. Okay, a little bit about our locations. So there's 4 of us in UAS specifically, and you can see kind of our footprint there. However, we are operating outside of those geological areas, so places, we have customers in Florida, on the East Coast, so our UAS division is really not limited to just those locations, but if you wanted to walk in through the door, that's where you could come and meet us. So there's our brick and mortar locations. Here's just showing you kind of what products we're covering and which ones we carry. So you can see we're not necessarily limited to just one manufacturer like a lot of people are. So we're really out there to provide the best product and the best software, really the best solution for whatever you're doing. And in order to do that, we have to be open to the entire market. So we have a lot of different vendors. They've been great to work with, and we'll mention them throughout the slides here. But obviously, there's not just one drone to do an inspection. So we want you to know what the options are and kind of what we've been using on each use case. Okay, looking at our series so far, our first one we did was April 9th, and Phil took the lead on that one, choosing the best tool for the job. That's actually been recorded now, and you can find that on our YouTube channel. I put the link to the YouTube channel on our chat, and then today we'll also go on there too. So I'm going to go ahead and, Phil, I'm going to take the screen real quick. So here's a little bit of our channel. Obviously with COVID-19, we've been doing a lot of videos, which is great for the end users. You guys can see a little insight of the product that we're carrying, what we're doing. So again, I put this link in the comments section, so you can find it there. But it's just Frontier Precision's channel, and it's got a lot of, we're doing a tailgate series. Just basically, when you go out for a demo, you're usually doing it out of the tailgates, and that's why we call it tailgate series. But just doing different product demos, webinars, everything will be uploaded to our Frontier Precision YouTube channel. So go there for a lot of great content. If you're looking for some information, that's where we usually point people, and that's where you're going to find a lot of our knowledge base there. Okay, so kind of the outline for today, we're going to go through just inspection strategies. So generally, what do you do each time you go and you go on to one of these inspections? But what a lot of people like to hear is kind of the case studies that we've done. So what we partnered with people to help accomplish and those things, and kind of what was the result of them. So we're going to talk about bridge inspections, gas detection, cell phone tower, power line, solar, commercial rooftop. And then if we have time, we put data in the cloud, because it's definitely a component that can really help you utilize the data much more efficiently than typical fashion. Okay, so again, getting into just the general layout. So you got to ask yourself, what's the best way to collect the data? And here I just kind of outline a little bit of some of the things you think about when you're talking inspection. So what kind of pre-flight activities? So each use case we talk about today, we'll talk about, you know, what's involved with the pre-flight aspect. There's a lot of things that people forget about, and it's not necessarily just as easy as, you know, flying up the UAS and being done with it. So what environmental considerations for each inspection? Inspections involve being very close to what you're looking at. You know, what are those distances you need to think about being away from? What's a safe distance? High altitudes, wind, those kinds of things that are involved in the environment. Oh, there you go. Sensitive areas, again, where are we operating at? Is it over people? Is it over power lines? Again, what kind of mitigation can you use in each of those scenarios to help you accomplish the inspection? And then what waiver might you need? So what are the regulatory rules that you run into? Is it something where you have to operate over moving cars, people? Is it at night? So those all those types of operations will require special permission from the FAA in order to operate that way. Okay, and then the part that is really one of my favorite things, and Phil is going to talk more on, but how do we utilize the inspection data that we're collecting? So here's a great picture of showing a model that's designed in Cad, and then compared to what actually got built or what it looks like now. So it's just highlighting areas that are different, and Phil will probably, if we get time at the end of this presentation, dive into it a little bit deeper, but it's a great visual, and it's a way that it can be shared to show people what did the inspection look like versus what do we want it to look like. So comparing A to B, what do we want versus what we have. And you can do that in a lot of different ways. You know, point clouds is one way, but having a report and that information on a report, and then just utilizing the cloud software itself. So sharing it within a cloud software program where someone can just pull it up on their phone or their computer, and then they can also make annotations or upload pictures on their side of things. So it's really exciting stuff, and we will dive into that towards the end of the presentation. Okay, so just to reflect a little bit on the last webinar, again, there's a link to the YouTube channel where we'll have that uploaded. It's uploading right now, actually, as I'm speaking, so you'll see that there. But Phil talked a lot about the spectrum, what we can see, what we cannot see, and really we utilize this quite extensively in all of our inspections, because a lot of times it's hard for us to see something with just to the naked eye. So we're going to talk a lot about you know, methane detection, infrared sensors, which infrared sensors can pick up different things. So we'll be utilizing this again. So I just want to put that up there so you guys can see those different spectrums that we'll talk about. Okay, again, these are just some of the verticals that use inspections. So we'll talk about infrastructure, utilities, towers, and some insurance cases that use them for inspection. Okay, so the first one we're going to get into is bridge inspection. So this bridge, Phil, if you want to do the next slide, this bridge here located in South Dakota. So this is just a Google image, and then I put the bridge inspection over top of it. So it doesn't line up perfectly because it's Google Earth, but the road is Bonson, so they call it the Bonson Bridge, and it was a deck delamination inspection. So the primary goal here was to see what areas of the bridge deck were becoming delaminated. So the equipment that we chose here was the Matrice 210. So this one's made by DJI, and it's the RTK version. And the reason we decided to use that one is it can carry the XT2 camera, which is a thermal camera and a regular RGB camera. And you can also have a zoom camera. So mainly for bridge deck delamination, we use the XT2. But the Z30, the camera there on the left, was also utilized just to do some general checks on some of the lower portions of the bridge. We also have the Mavic 2 Enterprise Zoom, which is a much smaller drone, but that one was used for kind of some tighter spaces to get into because it's small footprint and its sensors. It can get in a lot tighter areas. Okay. So the actual project setup, anytime you're using a thermal camera, you have to be very mindful of the environment that you're operating in. And the big thing is the sun and the temperature. So for you to really pick up bridge deck delamination, and I'll show you what that looks like here on the next slide. But before we move to that point, what you're really looking for before you head out there is this big temperature swing. And I'll explain this a little bit later, but you really need about 20 to 30 degree change on that day, that particular day that you're going to do the bridge deck delamination. Just so you have that much temperature change, that'll help you find those areas a little bit easier. And again, I'll explain kind of what's happening there on the next slide. But before we move there, we're going to talk about other pre-flight activities. Establishing lost link. There's a number of things that could happen. You could have it returned back to the takeoff point. Does that make sense? Do you have a bridge that has a lot of guy wires or something on the top part of the structure, or is it just a flat bridge? So you want to make sure you have the right lost link protocol if you want it just to hover or to return to home. Having the right conditions, so that 20 to 30 degree temperature change. And then how many people do you need? Generally with any type inspection, having an extra set of eyes just to make sure you're not running into things is important. If you're just doing a bridge deck delamination, you could probably go with 1 to 2 people. But if you're doing something where you're flying in closer quarters, you would be going more to 2 to 3 people. Most likely you would have some engineer there or whoever typically inspects the bridge there to view it real time to make sure you're getting the information that you need in the inspection. And then really trees. I mean, trees around the bridges are the biggest pain in the butts because you have to operate around them. And if anyone's flown a drone before, trees and drones don't go good together. So if you have a lot of trees surrounding your bridge, it does make it more challenging. And it also can block sunlight from hitting the bridge, which would affect the temperature of that bridge deck. So again, you have to keep that in consideration too, how many trees are around the bridge. And then waivers. So really the only waiver you would need potentially is a flight over moving cars waiver, which you can get flight over people or traffic. But if you're able to go during a time where it's not that busy, and what we did for this example here is we just would fly the bridge deck. If we saw some traffic, we would pause and move the aircraft to the side. So we had a spotter for that. And then we would resume the inspection once the traffic had cleared. So that might be practical for some people, but not for others. It just depends which bridge you're doing. So some bridges that will work, some won't. But you can also, we do have a parachute system for flying over traffic as well. So that is an option if you do have a busier bridge. Okay, so talking a little bit about what you're actually doing with the bridge deck delamination. If you know, the conventional method is actually dragging chains across the deck of the bridge, and when the sound of the dragging chain, it sounds hollow, that means you've gone over the delaminated spot. That works pretty good, and they've been doing it for a while, but you do need to close the bridge because you have people walking on it. It's not 100% effective. It's harder to find smaller spots. So with a thermal camera, you're able to visually see those areas. And with this example here, we actually compared the chain method versus the thermal camera method, and we're able to pick up more spots with the thermal camera than they were able to find with the chains. But the chain spots lined up pretty well with the thermal camera. The reason we're able to pick it up with a thermal camera is because, as you can see on the top right there, is that when something's delaminating, it's no longer in contact with each other. And so that's going to affect how heat transfers. So as the object warms up from the top, the thicker part there that's not delaminated is going to change temperature at a different rate than the delaminated part. The delaminated part is thinner, so it's going to heat up a little faster than the thicker part. So what we're looking for is that temperature difference. Usually it's not a lot. Usually it's around about a half of degree to a degree. But again, if you have a big temperature change, you can catch that rate of change a lot easier. So that's why we're looking for that 20 to 30 degree temperature swing. And then we're going to catch it on the second half of that swing to pick it up with a thermal camera. So you'll see on that earlier slide, the inspection took place at about 10:30 in the morning. So again, as the bridge was heating up, we went out there and mapped the deck of the bridge, and we were able to pick out the spots. So just a couple notes there on the left. You want to make sure you're using a high resolution thermal camera. It's pretty common that people ask us, hey, can I buy, a Mavic Dual or, these low resolution thermal cameras? and it doesn't really work very well, and most of it is in reference to the spot size ratio. This is a very small temperature difference that we're looking for, so really you need the best thermal camera you can get. There's a lot of white papers that talk about these things, so I'm just kind of highlighting it right now. But you really want the highest resolution thermal camera so you don't miss those details, because the details are already fairly challenging to pick up. You're going to want a radiometric camera, and what radiometric means is that the camera is actually just taking a temperature for each pixel in the frame. The reason you want that is for mapping. If you're going to create one large image of the bridge altogether and you want that geo-referenced, you need a radiometric camera. Right now, a non-radiometric camera would not be able to do that, at least in a reliable way anyways. So you're going to want a radiometric camera if you're trying to do that. If you just wanted to fly the drone and find the delaminated spot and then mark it as you're flying it, kind of thing, that would work. But if you wanted to actually make a, an orthomosaic or something, you would need a radiometric camera. Settings, you're going to want your thermal camera in high sensitivity mode, which means it's just going to put the camera saying that you don't have anything extremely hot or extremely cold. So it's going to make it more sensitive to pick up those small temperature differences. High overlap. So anybody that's done a little photogrammetry, you have to have a certain amount of image overlap. And for this camera, because 640 by 512 is actually not a lot of resolution when you compare it to your regular camera. Even your cell phone is going to have 4 times the resolution of that thermal camera. So you're going to need a lot of overlap to make sure that your orthomosaic is stitched well and that you don't have a lot of air in there. So again, excuse me, you're going to want probably around 80, and I think I have this in the next slide, but 80% overlap on the front and over 80% on the sides. We talked a little bit about the environment change. So again, we're going to look for that temperature swing when we're going to want to do the mapping of the bridge deck. And then we talked about trees and waivers already. So you guys got an idea there. On this next one here, give me 1 minute. Okay, so flight execution, ground control points. So ground control points are basically identifiable points that you can see in the image that we're going to mark much more precisely. So you can see the bottom right there, there's a picture of the surveyor who was marking a point for me. Lines, again, the sun will heat that yellow area up slower than the area around it, or faster, depending on the color. So I'll be able to identify that line pretty easily with a thermal camera. So he's going to mark that point. That way we can geo-reference our orthomosaic much more precisely. Other things that you can use is you could use the targets. Again, different colors, different materials will retain heat differently. So again, those are going to be things that are easily identifiable. Cracks are easier to pick up. So any of those areas you can mark as ground control points. Flight parameters, so relatively close flight. So 60 feet is not very high, but the reason that we have to go lower is because our resolution of our camera is not like a typical mapping camera. 640 by 512 again is relatively the highest resolution you can get in a thermal camera, but it is a really low resolution thermal camera. It's a low resolution altogether. So you have to fly close to your subject, 60 feet. You could fly a little higher, but the closer you get, the more detail you're going to get in the image. So we did 60 feet and then a high overlap of 80 and 80 on the side. So you can see there in the top right, that's just kind of what the mission would look like. You can fly it autonomously or you can fly it manually. Autonomously allows you to guarantee that overlap. If you do it manually, it's much more challenging, not impossible, but more challenging to get the precise overlap that you might need. Again, depending on your situation, it might be one where you need to move the drone manually like we did and then resume the mission as soon as the car goes by. So it could take a little longer than kind of that estimated flight time expected, but in this mission we were able to do it in one set of batteries. So we were able to get the data in under 20 minutes. Sensitive areas, trees, power lines, again, you'll be mindful of that because we're at 60 feet. And you can see in the bottom right there were some trees, but they were off to the side of the bridge quite a ways. So we really didn't have to worry about any of that. But what I typically do is I'll take the Mavic if I have it along. And I'll just do kind of a manual flight just to identify any obstacles and what heights they're at and what locations they're at before I even do an autonomous flight. So I don't have to worry about a potential collision there with the tree. The Matrice 210 does have some anti-collision avoidance, which is great, but I, again, tend not to rely too much on that technology if I don't have to. I'd rather just not have to worry about it not working and potentially hitting the tree. Again, waivers are going to be operating over people or moving cars. The FAA states unless it's part of the operation that you will need a waiver for something like that. Again, you can work around it by moving your drone if there's a vehicle or people coming, but in some areas that's not feasible, so you need to get a waiver in order to make that operation work. Okay, so what did we gather, or what data did we get? You'll see here, this is a report that you can make in FLIR tools. And it's kind of small, so I apologize, but if you watch the presentation later, you can kind of blow it up. But what that's showing you is there's these little spots, and you can kind of see that on the top picture. They're a little bit whiter than the areas of black, and in the middle, you can kind of see that paint stripe there. So I mark a couple spots there, and it gives me the temperatures in the top left. It also gives me the geolocation, and that's the geolocation of the image. So I could go back and stand at the center of that image since these pictures were taken straight down, and I could just go out there and have an idea, but it's pretty challenging. Again, that's why we make the ortho mosaic, but it gives you an idea what the camera is seeing. That's why I like this picture so much, is you have a regular image. That's what you would normally see on the top of the bridge. And then you have the thermal image, and that's where you're seeing these white spots. And those white spots are where the deck delamination is occurring. So you can see it's fairly clear and fairly straightforward, but the tricky part is making sure that you can go back there and identify those spots so they can be repaired. Let's see. So again, same notes there, rating metric, etc. So I think the next one here is the, okay, so visual inspection. So also, in addition to the thermal camera, you can use a regular RGB camera. And in this case, we use the Z30, basically to accomplish a visual inspection that you might do with just a truck. So you can see in the top right, that's, again, the traditional way of doing it, of just identifying things. Obviously, you can be more hands-on with that method, but a lot of times they're just looking for something that doesn't, you know, missing bolts or something like that, or a corrosion issue that might occur. So if you can lessen your amount of time renting that truck, you're going to save some money. And that's really where drones come in, is they can hit the high wear and tear areas. Usually engineers kind of have a pretty good idea where to look, where that corrosion might be occurring. And then, you know, for some situations, you still have to get a truck, but hopefully you can limit that amount of time renting it, so you're saving yourself some money. So things that you run into here is establishing a lost link. You don't want to return to home, because if you're underneath that bridge and you want it to return to home, it's going to try and climb, and that's not a good thing. So you're going to want to change that to just hover, and then you can reposition yourself to get the signal back. Also, the light and the sun. So with the visual camera, you want to have light on your side, so you don't want to be pointing the camera into the sun. So low sun angles, if you're pointing the camera into it, is not good. It's very hard to see what you want to look at. So if the sun's high or at your back, that's fine. But you have to be mindful of that, because that can affect your visual inspection as well. This one definitely requires a 2 to 3 person crew, because you'll have one person flying, making sure they're not running into anything, one person manipulating the camera, and then one person telling the person where to point the camera at, basically. So that'd be your engineer. And with a team of 3 like that, you can accomplish this inspection very easily. But if you're just doing it one person, trying to control the camera, trying to fly the drone, trying to look at something, very easy to lose your situational awareness and crash your drone pretty quickly. So again, I always recommend 2 to 3 people on an inspection like this. The data is video and pictures. A lot of times that works fine. That's more than what they may have had in the past. Maybe they take a picture or something, but if they want full coverage, usually video works a little bit better, but if they just want pictures of kind of some highlighted areas, that works well too. This is a GPS denied environment. What I mean by that is it's very easy to lose GPS signal. That's why the Matrice aircraft works very well, is it does have additional sensors to help avoid flying into something. But if it's a really tight area, I do prefer to use the Mavic 2 Enterprise because it has more sensors and it's a less expensive aircraft. Not that I've ever crashed one, but if it did happen, you know, you wouldn't be in as big a trouble as if you crashed a really expensive Matrice 210. So, but it does have sensors, it helps you avoid it. It alerts you anytime that you're getting close to something. So it does help you a lot, but you still want to have a visual on the aircraft so that way you know it's in a safe location. So definitely takes a little bit more experience to fly underneath the bridge. Okay, using the data on the bridge deck delamination. So you can see here is the ortho mosaic, and this was created with Pix4D. It's not the only software that does this, but this is one I used in this case. And you can see here I can make annotations. All the locations are points on this map. And Phil, the screen went a little gray there. I don't know if screensaver, there you go. Thank you. So all those annotations you can click on, they all have locations associated with them, elevation, so XYZ. You can label it if you'd like to. You can draw a polygon around it. So if you wanted to see how much area was delaminated, you could draw that around there and very easily get an idea how much bridge deck is going to be repaired, all on a cloud-based program. So I could share that with somebody and then they could go around and click around as much as they wanted to. You can export the points in a CSV if you'd like to. Again, the cloud software allows you to make the annotations. Maybe you're only going to repair half the bridge and you want to, label those points. You can export that data. So if you wanted to export this, you could put it into something like Trimble Business Center, and also draw lines, those kinds of things on your bridge if you wanted to too. So it's a great way of sharing the data there. Okay, make sure you have any questions, you type them in the questions on the right-hand side, but we're going to continue to move. Since we only have about an hour, we may go a little long, and if you have to take off, totally understand. This next one we're going to talk about is a gas detection system. All right, so the equipment that we chose here for gas detection is the micro drone system. It is called the Micro Drones M Detector CH4 long range. Phil, if you want to move to the next one there. Looks like the screen might have, there we go, thank you. So the pros to this system is it's designed for detecting methane gas. The aircraft is very quiet. It is larger, but it is very quiet. So if you're flying in an area that might be sensitive to noise, it's very hard to hear this drone. Long range detection of up to 300 feet. So you can basically fly 300 feet, which is above most obstacles, and still pick up gas. In our use case here, we actually flew it at 150 feet because the laser becomes much more effective the closer you can get to it, and all of our obstructions were below 150 feet. So the closer you can fly the laser, the better, but it does have a maximum range of 300 feet. It gives you live detection. So as you're flying this, you actually get notified if there is detection of methane gas, which is a really powerful tool because then potentially the operator could walk right over there and try and identify what the source is and report it and or fix it. A nice thing about micro drone system here is that the CH4 sensor is interchangeable, so you can interchange it with Lidar or cameras. So if you wanted to do a photogrammetry mission or a Lidar mission, you can interchange that sensor and still use the same aircraft. Okay, so a little bit of spec sheet here on the CH4 long range from micro drones. So again, methane being the gas that it picks up, natural gas are similar. It measures gas in parts per million, so it'll shoot out a laser, and that laser will pick up basically the parts per million reading throughout the atmosphere that it's shooting it through. There's the detection distance. So again, we put 300 feet, but it's 328. And then it's got 2 lasers there. So those are the class of lasers. Yeah. Okay, so setting up for this project. So here's just the station. And so we automated the flight plan, but you can again manually fly this, or you can do a mixture of both. We actually did that for where the pipeline ran in ground, is we did an automated flight, but then we manually flew it in an area that was a little bit more sensitive. was open to the public. So if there's anybody that was outside or walking underneath it, we could move the aircraft. So again, you can automate and you can fly a more manual mission if you'd like to. So what you want to do is you want to establish lost link. If something happens to the aircraft, what do you want it to do? Do you want it to pause? Do you want it to return to home? And that can all depend on the area that you're flying. If you're flying in town, if you're flying outside of town, do you have a lot of changing terrain, those kinds of things. The biggest environmental effect that you'll run into with this gas detection system is a wind. Wind will create drift and it will kind of dilute the gas that's coming out. So if you have a lot of wind, it's going to make this a not very effective method of finding it. Not that you won't find it, but it becomes much more challenging. It's kind of like if you're navigating the ocean and the wind is 30 miles an hour, it's going to make it pretty challenging, you know, if you're in a small boat. But if it's calm, you have no problem. Same thing here. So wind is going to have a large effect on what happens to your natural gas. Very low person crew, so 1 to 2 people. Obviously we had probably, I don't know, for this demonstration, probably 20 people just because they all wanted to see it in action. But the actual operators was just 2 people. You have 1 person operating the drone, and then we had the other person basically making call outs if there was any gas detected, but that could be done by 1 person as well pretty easily. Tall obstructions, that's the biggest thing because you have to fly at max 300 feet away. So you do have to look out for tall structures, buildings that may run into the aircraft or you may run into. Waivers, kind of similar to the bridge deck. Are you overpopulated areas? It just depends on where your lines and your stations are at. Most of the time you're able to get over those areas with no problem, but you may need to look at possibly an overflight of people waiver or something like that, or maybe even a beyond line of sight. Okay, executing the flight. So again, we did 150 feet, which again, we had no problem with because there wasn't a lot of tall structures. And we had the instant indication. So you can see on the bottom right hand, that's what I'm seeing on the screen. It has little X's that indicate no gas. So once I get a reading, it'd be a circle. And the circle would turn colors based on how much the reading was. So right there, there's no gas, no problem. And that's the instant indication. Now, if you missed it, there is a secondary way of looking up those indications we'll talk about here in a little bit. But again, manual flight, automated flight, we mentioned already, and the sensitive areas. So we'll move on to the next part where you can actually download the data here. Okay, so post-flight. So once you land the micro drone aircraft, you can actually Bluetooth the raw data from the drone to the tablet, and then you can see any reading. So in this case here, all the empty circles have no gas reading, and then there's some wind blowing from basically the bottom part of the picture to the top left part of the picture, and that wind drift is causing it to go over that road there. So that orange and yellow are actually indications of gas that it picked up as it went over there. So you can see the wind is drifting at that direction. Had there not been any wind, my guess is it would just be isolated over that one spot. Okay, the data that we talked about downloading, that's also accessible on the SD card. So here what it does is you have a CSV file with every point that it collects, which is every second, what the reading was. So the highlighted column, the yellow highlighted column is the parts per million value. And you also have the lat and long, and you also have the time that it was taken. What you can do is you can use something like an Esri platform, so a GIS platform. You can import those points and those values into that platform. So there's a picture of basically what we flew. So there was the line starting there on the bottom left of the screen, and it was going up into town there to the station. And all those little dots are readings that it was taken. If it was a high value, the circle would get bigger. So again, in Esri, you can change those symbols. If you wanted it to turn, purple when it had a high reading over 1,000, then it would turn purple. So again, Esri has a nice way of importing this CSV file into a visual, so you could just export it into a report, and you can say, here's all the values, here's what we flew, and you have that documented. And again, you can do this over and over and over again if you'd like to. But again, a nice visual there on the Esri platform for seeing where methane gas might be leaking. In this case, there was no leaks. Okay. So we're definitely biting off a lot today, and the next one we're going to talk about is cell phone towers. So cell phone tower inspections. Okay, again, equipment of choice. We did the Matrice 210. the version 2, and the biggest reason we did that is because it's not as susceptible to magnetic compass interference. When you get close to a large metal structure, it can affect the compass reading, and in a drone, that's a bad thing. So with the 210 RTK, it actually relies on the GPS on the base station to get its heading and position location. So if that compass fails, you're still able to fly very precisely with very little movement and having to worry about it drifting into a tower or something like that. You can also fly multiple payloads. In this instance, we use the Z30, which is a high zoom camera, and the X7, which is a high resolution RGB camera. So it's just a regular camera that takes high megapixel photos. And with those cameras, here's just a good example of what you can see with the zoom camera. So every industry has kind of a standard, especially as drones are becoming more and more popular. They're going to have things like how far should we keep away from the tower, what's a safe distance, some kind of general safe operating practices. So I believe NATE is the National Tower Erectors Association, and they kind of publish their standards. But what that does is that says, hey, I can only fly, within 15 feet of this tower, because they don't want anybody crashing into it. They feel that's a safe distance. Well, now I have to find out a way to get the information off of what I want on the tower by staying that far away. So here's a great picture of us actually being about 25 feet off the tower, so well outside those standards, and zooming in and still getting serial number information. So azimuth, all this great information, antenna manufacturer, tilt, all those things on the back of the antenna without actually having to climb the tower. Having people climb the tower is very expensive and lots of liability. So if we can do everything that they would do by flying with the drone, we would save some money there. Obviously towers, they get very tall, so the wind changes as you get higher and higher. So that's something to take in consideration, especially if you're using a lower grade of aircraft that doesn't have as good a position hold. You want to make sure you're not going to drift into the tower, so you want to be very cautious on that, and have some procedures for your aircraft and what the wind limits would be. Guy wires, how we worked around guy wires in the past is we just take off and go straight up, and if we have to move the aircraft laterally, we land and then we reposition the aircraft. That way our depth perception never becomes an issue with guy wires. We don't have to worry about hitting them. This typically takes another 1 to 2 person crew. Again, you're going to be manning the camera and the drone, which works fine at 25 feet. You're not going to have any issues, but at the closer you get to something, you definitely want to have someone focusing on the camera and someone else flying the drone. What you might run into is signal jamming. So if you fly in front of a microwave antenna, there's a good chance you may lose your signal. If you're working directly with the tower operator, they may be able to lower the power output of the antenna. But if you're not and you need to inspect the tower, you want to plan for possible signal jamming. So what happens to your aircraft if it loses signal? Do you want it to keep climbing? Do you want it to descend? Do you want it to hover there? In most cases, what we've done is we have it descend. So we have it descend, gain signal back, and what we would do is we'd move a little farther away from the tower and then move past that antenna again. Eventually that signal loses strength. Even 10 feet can make a big difference when you're sitting in front of an antenna. Okay, waivers here. Usually don't have to worry about any waivers. There's not a lot of crowds around people around the tower. There's not people walking under it. Usually they have a fenced off area, so it makes it very easy to operate around. So you really don't have too many waivers or anything like that that you have to worry about there. Okay, again, there's another example of the zoom. This zoom camera that we use, 30 optical zoom. Again, you can be very far off the tower, get serial number information damaged very easily with this kind of inspection. Okay, well, what about the X7? You're probably asking, how are we using that in the inspection? Well, with Pix4D Scan now as a new product that they launched, you're actually able to automate the whole inspection in a very few clicks with their new software and their app that they have. So what it will do is it will take pictures spaced out perfectly to reconstruct the whole tower on the software. And on that software, will automatically inventory your antennas, make notes on the sizes, annotate the tilt, all those things through Pix4D scan. So it's just making it easier, and this is a trend that we're seeing a lot of because of the ability to have to have a certain level of skill. What they're doing is they're now having the software do the whole inspection for you, and all you do is you just basically sit there and watch the drone do its thing, and then you pull up the software and go through in the inspection of the software. It's pretty slick. I think I got another picture of it. Okay, so there's a kind of visualization of the tower. So all those little yellow things floating around our camera views. So again, it's reconstructing the whole tower. It's highlighting the antennas, taking inventory of the antennas. You can click on anywhere in there, and then it will pull up the actual pictures taken. So if you want to make an actual visual inspection, you can click on something and then see all the pictures that have that part in the picture and make an annotation pretty quickly. It also allows for reports, so you can take those annotations and export them in a PDF. You can make measurements, so if you're curious on angles or measurements of antennas, those kinds of things, you can make measurements within the software and identify locations. So very easy to inventory your towers and make sure you have everything on there that you're supposed to. Exporting as well, so you can export through the cloud, so you can share this so they can make annotation as well. Otherwise, like I said, you can just make a PDF report and give it to them so they know what the inventory looks like on there. Okay, next one here is power lines. So power lines, aircraft of choice here is the Quantum Systems Tron. This is a pretty large vertical takeoff and land system, but it has the ability to do RGB or Lidar. You can't do both at once, but you have to pick one. But the big advantage is the amount of flight time you get out of this. So anybody who's flown multi-rotor probably knows that you're probably limited to about 30 minutes because you have 4 motors that's running and it's lifting its weight constantly. With a fixed wing aircraft, you have the weight of the aircraft being supported on the actual wing, and you just have the motor pulling it forward through the air. It allows it to have much larger payloads and flight times. So what this does is it kind of mixes them. So you'll see some of the propellers bent back there. It takes off like a multi-rotor and then it transitions into a fixed wing. So you're going to get the benefit of both worlds. 90-minute flight time, which equates to about 3,700 acres, which is quite a bit of land to cover. If you did that linearly, you get about 4 miles, which is why this fits the power line inspection so well, is because power lines run for a long time, and if you can do 4 miles in a shot, you're going to cover quite a bit of ground. With the Lidar, you can see there's accuracy of 5 centimeters. So the use case we're going to talk about here is vegetation and how it approaches to the power lines. Let's see here. So this is a great picture in the bottom right there. Utilizing some cloud software, it will highlight how close the trees are getting to the power line. So if you have to have a certain distance there, you can specify what that distance is, and it will automatically highlight any areas that it picks up within that distance. So again, what you'll run into here is, standard practices is you're not flying directly over the power lines, but off to the side. So you'll probably have to do a swath on one side and then it's a flight back on the other side. And then you'll get every angle with the Lidar and be able to measure distances from the trees to the power lines. So it's very fast. Once you capture this processing as well, you're just doing points. So it's a very fast process. And you're able to also, one of the benefits of Lidar is due to some degree of vegetation penetration. So you're actually able to pick up the ground and where the vegetation starts and stops. Reduced need for control as well. It's a good point. You're not going to be setting ground control points as frequently with the Lidar. So the advantages of a regular camera or RGB camera is now you actually have an image associated with your inspection. A lot of people use like a multi-rotor so they can get more detailed of each tower because they're not as necessarily worried about the power line at that point. So they're inspecting things like insulators and arms. So again, they're going to be using these cameras. You can use this on the Quantum Systems Tron as well and get images like this. But again, it's going to be a little less detailed than you might need if you're inspecting something like an insulator. So yeah, you get a little bit of both. You might get a mix. You might have to just do vegetation with something like the Lidar and then flying towers on a more manual basis with a multi-rotor to get the exact points you need to inspect. Okay, so again, what pre-flight looks like for this, again, you always want to establish what happens when you lose link. The Tron has a very large or very long range. I think it's something like up to 5.3 miles. But what that equates to is you're gonna have to figure out some type of beyond line of sight waiver or some way to keep it in line of sight of however big your crew is. It's very automated. You're gonna have maybe a 1 to 2 person crew. So you know, unless you're spacing people out to kind of do a visual line of sight waiver. So you always keep line of sight of it, but typically you'll just program the mission and let it fly. Because of the large area you're covering, you want to make sure you're accounting for terrain change. So if it's going over hills or mountains, you want to make sure you have a surface model that will allow the aircraft to follow it, or at least take that into account. So that way your aircraft, when you take off, understands that there's a mountain over there and it actually follows the terrain and doesn't fly right into the mountain. So something that you definitely want to look at when you're doing that. Okay, how do we use this data? It's so you have 20 miles of power line. That's a lot of information to process and look at. So really, what's the most effective way of doing that without having a supercomputer and 13 people working there on it? It really comes down to using data in the cloud. It processes large data sets very, very well. You can share it. You can have it do automated things like the vegetation that we talked about, highlighting areas that it's getting closer, like in this example on the right, is you can see how close the vegetation is getting to the power lines. So again, you can have that all automated, and all you have to do is pull it up and take a look and know that, hey, we have to trim back some trees. And if we wanted to, we could measure the area of trees that need to be trimmed, all in that software. So again, data in the cloud makes things a lot easier, a lot more accessible to everybody, so you're able to share it versus having one large file that you're exporting and then having to send to people. You could even make this a report. So again, you can export this as a PDF and say, this is the location, this is what needs to be done. It keeps it very simple for whoever needs to do the job there. If they're going to be trimming the trees, they get a good visual of how much needs to be worked on. Okay, again, you can add pictures. So in this case here, in the cloud, you're able to add this picture and put it in there with the location. So if someone's going out there to work on it, they know the exact location, what the damage was found, and that's all uploaded and shared in the cloud. So again, collaboration, annotations, it really works well into the whole workflow. You don't have to have 10 supercomputers. You can have this shared very easily with anybody on a regular computer or tablet. So very easy to work with. Okay, we got a couple more. Our next one is solar inspection. This one's a little bit shorter. It's pretty easy. So similar platform, you'll see we use this one a lot just because it does have a swappable payload. It makes it very flexible. And the XT2 and the X7 being the primary payloads we carry here. But the reason we're using this is for very good position accuracy. So being able to locate a damaged panel and knowing exactly where to go to fix it. Okay, again, thermal, the benefits there, you can see areas of increased resistance. So if you see on the center picture there, those areas that are glowing, those are areas that have high resistance. And this isn't necessarily limited to just solar panels, but electrical inspections, insulators, those kinds of things, you'll see heat differential based on that increased resistance. So that makes it a very powerful camera when doing those types of inspection. Again, zoom we talked about already, but obviously you can zoom in and look much closer at the problem. Okay, so setting up for this, very important to know the sun, where it's located, temperature. This can be accomplished pretty easily with a one-person crew. You really don't need a second person there, but if you do have to have someone, it is nice to have a larger monitor to view on, so you don't just have someone looking over your shoulder. And that's true with especially the bridge inspection. If you have anytime you have to involve an engineer, you'll want to have a separate display just for them. That way you don't have to worry necessarily about you having to scramble and find the drone, and you're carrying the monitor, the engineer can't see it anymore, so you have a separate monitor for them. Will make it work a lot cleaner, so they can see things in a lot better way. So a daylight monitor, daylight TV works really well. Sensitive areas, so since you're around solar farm, you're probably gonna have power lines coming from that, so you just want to be aware where they're located. If you're flying an autonomous mission, that you don't have the mission planned into those power lines. Okay, so on the bottom left there's a map. Again, an ortho mosaic of a solar field. This is typically what people want to see. Then they can get a pretty good idea what's being affected, what's happening. Again, cloud software can help you identify where those areas of problems might be. What people typically run into, again, with thermal cameras, like we talked about the bridges, you need a high overlap, so 80% overlap is typically what you'll need, and you'll need to be pretty close. So with this inspection, you need to be about 150 feet. So it's a little bit farther away than the bridge, but there's a lot more contrast on this high resistance than what we had with the bridge. Also, you want to make sure you take reflection into account. So the sun, typically with a solar panel, you want it pointed directly, and that's very true with a thermal camera too. If you don't have a nadir angle, so a straight on angle or perpendicular angle, you're going to get reflection in from the background. So you want to take these images straight onto the solar panel, which is a little bit different than typical mapping. So if you want to find out what your solar panels are tilted at, that way your camera can be straight on to get the best reading for the solar panel. Okay. Okay, here's again the solution using cloud software. This cloud software is called Lidar AI, and what they can do is they can inventory all the panels, and you can see that red located there on the panels. It marks anything that it finds abnormal. So again, it's just an automated process where you basically just go out and fly the mission within the given parameters, so 150 feet. The images are taken straight on with the solar panel, and it will automatically stitch everything together for you, and it will also give you the inventory of how many panels there are, which ones are damaged, etc. So it makes it very easy for you to do. It takes very little time. You're not spending any time processing. It's doing all that for you in the cloud, and that's Lidar AI software working on that. Okay, commercial rooftop inspections. So Phil wanted to talk a little bit on this, and so I'll hand it off to him. But one thing I forgot to mention is that we do have licensed thermographers on staff, and anytime you're using a thermal camera, I would recommend some level of thermography training. We're all level 1s, but you can get all the way up to level 3, which we plan to do eventually. But the Infrared Training Center, and if you have questions on that, they're the ones right now that do training to get the level 1 thermography. But it's a very great class. It's a week long. That goes through things like solar loading, emissivity, things that you'll want to know if you do get into this this type of use case. Phil, you can go ahead and take it.
Sure. Can you guys hear me all right?
Yeah, we can hear you.
All right. So yeah, I just wanted to spend a couple of minutes talking about commercial rooftop inspections. And this will be a little bit theoretical, but to kind of go quickly and just show you the potential options and how it's being used currently in this space. So when we're talking about commercial roofs, there's generally 5 factors that affect the lifespan. That's the installation itself, regardless of how well it's rated. If it's badly installed, then we're going to have issues. The slope of the roof, You know, the flatter the roof, the more likely water is going to pool on its surface. And, you know, I'd say probably about 90% of commercial rooftops are flat or very slightly sloped. And so when water doesn't flow off the roof, it's going to find that lowest point and stay there until it evaporates, essentially. So these low spots are often where leaking starts and damage starts to happen. Ventilation, you know, ventilation helps prevent the buildup of heat and moisture. When we have hot summer temperatures in the attic, as well as hot sun, you know, coming down on top of the roof, we're essentially baking any materials that are on top of that roof. Maintenance is also something that affects this greatly. You know, routine inspections and maintenance can prevent those small problems from becoming major ones. And then weather, of course. Harsh weather can cause direct damage to roofing material when we have high winds or hail, but also everyday exposure to the elements does a lot of damage as well. So these are just some of the roofing materials that are commonly used. If you're not really in the industry, it's not going to matter to you too much. If you are, you're familiar with these. As you can see, these are typically rated, again, with proper inspection and routine maintenance between 20 and, you know, all the way up to about 40 years. Typically, though, you know, we're seeing the average lifespan of a commercial roof being 10 years. What does that mean? It means that either people are not inspecting the roof as often as they should. You know, when there are no problems, out of sight, out of mind, a lot of times these roofs don't get inspected. You know, and because of this, and, you know, along with lack of maintenance, as well as issues in installation, you know, the commonplace is about 40% of all commercial roofs are going to develop a leak within the first year of service, which is kind of crazy when I first heard that. But of course, we can last as long as 20, and we saw some of them up to 40 if we're really correctly installed, we're having routine maintenance and the like. So just a little bit about how we utilize solar energy to help us in these inspections. So if we have a situation where there's a leak and there's water intrusion going into the insulation below the surface, wet insulation absorbs more of that solar energy, meaning it's going to heat up more during the day. And then it's going to release more of that stored solar heat at night. So we can take advantage of this with thermography. Because of this action and reaction, thermography allows us to visualize things that are not within that visible spectrum. So we can see these temperature differences with cameras like the XT2 and the like. You know, these theories were not developed by drones by any means. Thermal has been used for rooftop inspections for years, generally handheld. When you're getting up to extremely large commercial rooftops, you know, hundreds of thousands of square feet, much like surveying with boots on the ground, we're talking an extreme amount of time to just get the information that we want. So what drones allow us to do is put that technology into the air, cover a much larger space and more inaccessible spaces in a shorter period of time. And so when we look at this thermal imagery, as you can see here in this image from FLIR, you know, this can give us an indication of water intrusion at a very simple level. Typically, these are the pieces of gear that we'll use. And I'll talk about a little bit how we do this. So we generally will want a 2-flight scenario. We're going to do a daytime flight to create that you know, red, green, blue, visible spectrum, orthomosaic, and individual imagery. This is going to allow us to actually see what the human eye can see. And then we'll do an evening flight and geo-reference and lay that on top of and be able to kind of go between the daytime flight and that thermal orthomosaic to get an idea thermally what's going on, and then reference that to a visual section on the roof, often because thermal, especially when we're flying at night, which we'll talk about why we need to fly at night in these situations, to be able to reference those back and forth. Based on the way that colorization works in thermal photography, essentially what the colorization does is it grades the colors of the differences in temperature across the scale that's available in that individual image. So this is why it's important with that evening flight that we're not only creating that thermal orthomosaic, which is going to be colorized across the scale of the entire stitched image, which of course is taking place over a period of time from takeoff to landing. If we're talking a couple 100,000 square foot roof, this could be a substantial amount of time between the start and the end of that survey. So it can be a good indicator to see differences, but then we're going to want to dive into that individual imagery, the individual thermal images that are colorized individually at the moment of the picture was taken or the image was taken. And so we're actually able to see much more detail in those individual images and much more accurate readings. So the ASTM developed a standard for this. This is not, again, just for drones, but there is a national standard for defining the methodology that should be followed by thermographers who use handheld cameras to inspect commercial roofs. Now, we've taken a lot of these standards because we are still using, FLIR that makes the XT2 that I showed. They make a lot of these handheld cameras. And so the methodologies on how we are going to collect this data are going to be fairly similar. Now, I know we've gone past the hour, so those of you that do need to take off, feel free. We will be providing, as we did with last week's, a recording of this webinar, but we're going to go ahead and wrap up for a handful of minutes here and finish the presentation for those of you that want to stick around. So we can use this, the ASTM standardization. This is actually a document, C1153-97, that actually lays out how do we collect this imagery to make sure that we get the best data back from that imagery. And so that includes a few, this is really just a snippet of some of the rules that we have converted over in my experience and what I've done with some commercial rooftops over into the drone world. So we want to make sure there's no rain within the last 24 hours. There's no ponded water or debris or ice or snow or really any piles of aggregate on top of that roof that can affect our readings. And we do want to conduct that survey at least 30 minutes after civil twilight. So that's an hour after sunset. And that gives the roof a chance to really cool down in the areas that are not being affected by water intrusion, having water underneath. And then the water or the moisture that may be in insulation below that surface is going to cool at a much slower rate. So what that allows is for us to see those temperamental differences in the imagery. And so we need to actually conduct that survey a little bit after sunset, so at least an hour, of course, when talking about waivers, this would of course require a night waiver to fly in the evening. As Mike mentioned, we get a lot of questions, regarding the Mavic Dual and also, the Parrot and Nafi Dual. These are still great imaging systems for thermal. Most of them are, both of those systems use the same radiometric thermal sensor, but it's at a much lower resolution, and we're simply just not going to capture the imagery that we need for a large structure, at least not in the time that we need to collect it in. A couple 100,000 square foot roof, we're talking multiple hours of surveying at night. Even with something like the Matrice and the XT2, you would have to fly substantially lower and extending that survey to essentially longer than it's even dark outside. So we want these surveys to also, both the daytime survey and the nighttime survey, to be conducted within the same 24-hour period, so we can identify if there happens to be some pooling water or items on the roof that the thermal imagery cannot give us the information that we need to delineate. We need to have that imagery being very similar, at least in a similar time period. One other thing to note on here is, after warm, cloudy days, cloud cover can reduce both the daytime insolation and the nighttime radiational cooling. So if we have a really cloudy day and it's not nice and sunny, where that roof is really able to heat up and then cool down fast after sunset, we may need to delay or do this on a different day. And if we're kind of not sure whether you know, it was hot enough or clear enough to do this, what we'll generally do is repeat the survey on the first section of that roof right before we leave the site to make sure that we didn't miss anything or that we gave it enough time to cool down before we made that flight. And then one last thing is that anytime we have a dew or frost on the roof, we're probably going to want to delay that as well. So if there's a lot of precipitation, even if it hasn't rained, you know, this is going to definitely decrease the intensity of thermal anomalies. So we want to be very careful to either delay or maybe just not even conduct the survey under these conditions. All right, so I just wanted to spend some time to talk about data in the cloud. Mike mentioned quite a bit about you know, some of the data being in the cloud and how this can affect the work that we're doing. And so this concept of the digital twin, this is something that, you know, in most of my career, I've actually worked in the cloud space as far as, you know, doing cloud-based processing and cloud-based analytics with the data that we get. And so while a lot of the other guys have concentrated on the front end and the processing and getting really good quality data, I've concentrated a lot on taking that quality data and really getting as many business insights as we can out of it. And so this concept of the digital twin really goes across any number of industries, every industry that we've discussed in last week and that we'll discuss going forward. We're really creating this twin digitally in a cloud-based or computer system that allows us to access and utilize this imagery that we've collected to extract information and change the way that we do our business. And so I just wanted to take a second to dive into one of these cloud platforms that we carry, which is Delair, and show you guys a little about what this looks like. And try not to keep it too long on here, but spend just a few minutes going between some of these items.
Yeah, while you pull that up, Phil, I'll answer a couple of questions. It looks like Nathan's been able to get to a lot of people. One of the questions was on methane gas detectors. We talked specifically about micro drones solution, but DJI also has a solution too. It just wasn't used in this example called the U10. And if you'd like some information on DJI system, just feel free to reach us with an email or anything like that, but it does a very similar thing in detecting gas using the laser method. The other question I had in regards to solar panels and kind of the temperature swing we've been talking about, it's not as critical when you're doing with solar panels. What you're looking for with solar is that you have a lot of energy coming in on the solar panel. So what that means is the sun is shining on it, its current is flowing through it, and that's where you're going to pick up the resistance in the panel. So obviously nighttime would not really benefit you at all when you're doing a solar inspection. So that's just a couple of those questions while you're going up. I'm pulling that up.
Okay, so we're pulling this up. So give me 1 second, guys. Get this to be full screen.
Looks like we have a couple of questions. Right. We didn't include pricing on any of this, so if you do have questions on what this equipment costs, let us know and we'll be happy to send you some pricing individually. But yeah, we did not include that on our presentation.
Okay, so can you guys see my screen here?
Nope, just seeing the organizer screen. Frontier, there it is. Now we're good.
All right. Okay, so what we're seeing here, this is the Delair AI platform, and so Delair, and we talked about this slightly last week, and we're going to dive into it a lot more next week as far as cloud-based versus local processing. But we're not going to talk about processing right now. We're going to talk about this data utilization. So this is basically, we call this it's a demo site for oil and gas. It's basically a construction of a tank, of an oil tank, and but don't think about so much of if you're not in that industry. What I'm really trying to show here is, in general, whether it's construction, surveying, bridge inspections or instruction, any inspection of existing infrastructure or monitoring of the progress of building that infrastructure and maintaining that infrastructure can really be applied here. So what we're seeing here is a Lidar scan of the area. So we can interact with the point cloud, and as we go in, this is not dissimilar to what you would see in other point cloud software, such as Trimble Business Center or things like this. But when we get this data on the cloud, it opens up the ability to do a handful of things. I'd like to refer to Delair and systems that are similar as kind of like a Dropbox or box for whatever industry geospatially that you're working in. So that could be oil and gas, of course. It could be construction, could be surveying, could be inspections for any of these. And so what we can do is we can aggregate all of this data, not only just process data in this system, but we can actually upload data from other systems into this system. And as long as they're geo-referenced, we can interact with them simultaneously. So again, what you're seeing here first is the actual Lidar scan point cloud. So I can zoom in and interact with this. We can make annotations, points, lines, communicate about those annotations with other colleagues from another side of the country, world, city, whatever. And all of this data, even though it's a very large data set, a supercomputer is not required. Just a simple, quick access to the internet, and you're able to access and interact with this data without a very high-end computer at all. So where this really starts to gain magic is when we start to input design plans along with the as-built things that we're seeing here. So I can do things like import a 3D Cad model. So what we did here is we imported a geo-referenced three-dimensional Cad model and just simply placed it over that point cloud scan that we did. And now we can see where this tank is going to be, if it's in the location that I want it to be at, if there's any structures, trees, obstacles that could go into construction of this, if there's a problem. Once we actually build the tank, we can then add the Lidar of that tank. So now we did another Lidar scan and basically extracted the point cloud of the tank itself because we already had the ground surface on another layer, so we classified it as a different item. And now we're able to look and see the Lidar scan of the tank after it was built. And now, since we have all of these bits of data in here, both the truth, the ground truth, the 3D design, and the Lidar of the real tank, we can then do things like change map on the Lidar scan that we did. So what we did is we imported Delair. These are just off-the-shelf analytics, and we can do change detection between two objects. So what we did is we compared the Cad model plan to the as-built Lidar scan of the tank. And again, this could apply to a bridge, to a building, to a road, to whatever you want, to a haul road on a mine. Your imagination is the only limitation. And then we did a differential between these two items. So we can see we have anything in red is substantial difference, anything in blue is almost no difference, and then it color grades between. So what we have here is just some simple hail damage on top to be expected on top of the tank, but then we have something going on here with the door. So we know that this is essentially a virtual inspection where we can compare and say, hey, we need to go look further at that door. Was it left open? Was it damaged? What's going on? Did somebody try to break into it? And so just giving us an idea of where we are at in a moment in time versus where we should be is one of the things that these platforms offer. The next thing I'd like to show you guys real quick is a power and utilities Lidar distribution line inspection. This is kind of the same idea. This is actually where we got some of the screenshots from Mike's presentation. And so what we're looking at right here is a handful of things. We have a basic layering of the point cloud of the flight that we did. If we actually click on this layer, we can change a few things. We can mess with the intensity. We can actually look at an elevation difference of what we're looking at here. We can actually break it down into the classes. So they do classification of Lidar point clouds. Even if you're not processing this data, when we're done with the LiDAR processing, we end up with an LAS file. So we can import that in and then interact with it with other bits of data or just classify it in and of itself. So we're seeing the different classes here. And then if I start to add the span, so we actually digitize all of the power lines. And so we can actually see the drooping of the power lines, where they're running. And these are actually digitized versions of the Lidar scan. So one of the benefits of Lidar is with that point density, and because it is a physical measurement, it's a laser actually reflecting off of a surface, we're able to pick up things like power lines where traditional photogrammetry often does not. And so we're able to see those items. And then once we have those digitized, we can then take those 2 bits of data and create maps that show where this vegetation may be encroaching on those power lines. So as we zoom in here, find an area here that actually shows it. Vegetation encroachment, intensity. Let's see here.
As he's pulling up too, it's basically that same thing that we're looking at on some of the screen captures is, there you go. You can see, again, areas that are getting very, very close to the power line.
And then they colorize these and rate them according to, how close are they actually. We're obviously dealing with hundreds and hundreds or thousands of miles of power line. And so you can rate, what is the area that I need to concentrate on, and based on giving that information to the boots on the ground, they can say, we are either in real danger here and we need to get out to this immediately, or we have a little time based on the growth speed of these bits of vegetation.
Yeah, this is a good example of a large project too, and it didn't take a supercomputer. It's handling it fine, and you're not having any troubles navigating. It does take a little bit to load it sometimes, but again, this is miles and miles of power line, so a lot of data all being manipulated on just a regular laptop. So again, I'd just like to thank you guys for attending. If you have any questions, just reach out to us, and we'd be happy to work with you or happy to help you out. So I hope you learned something. Phil, thanks for walking us through the software and the flat rooftop. I appreciate the help.
Yeah. Next week, we are going to talk about photogrammetry. And so we'll talk a little bit about local processing versus cloud processing, some of the sensors that we use and the settings, as well as the equipment, the different drones, and compare and contrast some of those items. So don't miss next week as well. It's going to be good. Thanks for joining us.